Alright, so in this video we're going to talk a little bit about completing the square and getting a quadratic equation of a parabola into vertex form. So let's start out with something pretty simple. X squared minus 4x plus 1 is the equation of your parabola, and you notice right away that this cannot be factored. So what is completing the square? Well, it's the idea of forcing the equation to factor into something pretty easy to work with. So that's what we're going to do, is we're going to force this equation to be factored. And the way that we're going to do that is considering the first two terms of our quadratic side. So the x squared minus the 4x. We're going to look at those, and I'm going to rewrite this equation and give myself a little bit of space. And that constant number of plus 1 is going to hang out to the right there for a little bit. And the idea is, when you complete the square, you want to take that x term, just not the x squared, but just the x term, and look at the coefficient, which in this case is the negative 4. And then you're going to take half of that negative 4, which is negative 2, and raise it to the second power. And what that's going to do is, when we add that in, and notice I added it into the left side as well because it's an equation, what that's going to do is it's going to force what's inside the parentheses to factor into x minus 2 raised to the second power. And that's the whole exciting thing about completing the square. Now, I had to add the plus 4 in on the left side. You see that in blue that I added in there. The reason why is because it's an equation, and if I add something into one side, then I've got to add it into the other so I can balance it out. Alright, so here's the next step, where you see that the quadratic is now factored into x minus 2 raised to the second power as a quantity, plus 1. And now, to get this into so-called vertex form, I am going to subtract the 4 from both sides, and I end up with this. Y is equal to x minus 2 raised to the second power as a quantity, minus 3. So the vertex is going to be 2 and negative 3. It's pretty easy to identify at that point. Now, completing the square is a nice process unless your quadratic term has a coefficient that isn't 1. So let's take a quick look at one of those. And I go to the next slide, and here's an example: 4x squared minus 8x plus 5. And I'm getting ahead of myself here, but that's all right. 4x squared minus 8x plus 5. Now, the idea here is that when you consider those first two terms, the 4x squared and the 8x, you want to take out a common factor. So that's what I'm going to do here. And I leave myself just a little bit of room, and you notice it becomes y is equal to 4 times the quantity x squared minus 2x, and then the plus 5 is outside the parentheses, just like it was in the previous example, where it needs to be. And when I go ahead and add in what I need to do to complete the square, it's half of that linear term, but in this case it's no longer the negative 8, it's the negative 2. So negative 2, half of that raised to the second power is going to be plus 1. So I put that in. But the problem is that it's subject to the distributive property. So I really didn't add in 1, I added in 4 times 1. Now, where am I getting that 4? It comes from the outside when I pulled out that 4 in really the first step. So there you go. You see on the left side there I added in the plus 4 to account for what I did on the left and the right. So now it factors, which is pretty slick. And then I can move that 4 over to the other side, and I get y is equal to 4 times x minus 1 quantity raised to the second power plus 1. So my vertex is 1 and 1, and this is going to be a parabola that opens up. So I hope this little tutorial was helpful for you, and we'll see you in class.